Hello, welcome to another session, and today we'll be considering how to simulate a compressor. So we're still working on our tutorial Hysys simulation case. So I'll be loading as new. Okay. In our previous class, we learned how to simulate an expander, and today we'll be considering a compressor. So this is the compressor icon, so I'll click on it and bring it out. So let's check stream 2. Stream 2 should be a pure gas. Okay, now what you should understand is that your expander or your compressor will not solve if you have any liquid in your inlet stream. If you have liquid in your inlet stream, your expander or your compressor will not solve. So your vapor fraction must be 1 if you must use an expander. Okay, water or moisture is not permitted inside the compressor or an expander. Okay, so we'll be using stream 1. Stream 1 is a pure gas. Stream 1 is a pure gas. So we'll be using stream 1. I need to double click on this to open it. So the inlet stream is stream 1. My outlet stream, let me call it stream 4. And my energy stream, let me call it comp HP. Comp HP. I've told you how I name my energy streams. It must have something to do with the unit operation I'm designing. Okay, this is a compressor, so I have to call it compressor HP. That's the power of the compressor, the energy needed to power this compressor. Okay, so everything has been defined apart from the duty. Now let's check what's the pressure of the inlet stream. The pressure of the inlet stream is 241 kilopascal. So I'd like us to compress this gas from 241.75 kilopascal to 400 kilopascal. So all I need to do is to define my outlet pressure, or I come over here and define my delta P. And we already know that the delta P is the difference between the inlet pressure and the outlet pressure. So since I know the outlet pressure, I just come over to the worksheet under the pressure column under stream 4. I'll have to type 400. Okay, because remember we are compressing from 241 to 400 kilopascal, so I'll type 400 kilopascal. Automatically dissolves. So if we come to design under parameters, we'll see the duty of this energy. So we need 4.6359 kilowatts to power this compressor. Okay, that is if this compressor is operating at an efficiency of 75%, adiabatic efficiency of 75%. If it is more than that, let's say 80, definitely the duty will decrease. Can you see that? So the higher the efficiency, the lower the duty. So if we take it to 60, the duty will increase. Okay, so to reduce the duty, we have to increase the efficiency of the compressor. So let's say our efficiency is 75, take it back to 75%. All right, so this is where you choose your curve inputs and all of that. So you have to tell Hysys if your compressor is centrifugal or reciprocating. All right, if it's reciprocating or is centrifugal. Okay, so that's how to change it. Now you come to performance and check for your adiabatic head and all of that factors. The power, your power is 45.65 kilowatts. So that's the amount of power needed to run this compressor. All right, so that's how to simulate a compressor. That's how to simulate a compressor in Aspen Hysys. I believe you've been learning a lot of things from this tutorial. At the end of this class, we'll see how we can bring all these unit operations together to form a particular process. Okay, now I want you to learn how these things work individually so you can know how to connect them together when designing your full process. Okay, so see you in the next tutorial.